First video, we're going to talk about what you should be very familiar with, known as the Cartesian coordinate system. Now, this was a way that we can locate points on a flat surface and actually put numbers to them, right? And we do that through what's called an ordered pair. But before we get to that, the Cartesian coordinate system, real quickly, we have two number lines. We have the horizontal number line, which we call the x-axis. I don't know if you can see that. And you have a second number line, vertical number line, which we call the y-axis. Of course, a horizontal and a vertical will intersect at a 90 degree angle, or make four 90-degree angles, right? And where they intersect, we call this location the origin. And when we divide, a plane, a flat surface, into, use two number lines to divide this plane, you're dividing it into four regions. We call those quadrants. So let's get rid of this. We have four what are called quadrants. This up here is known as the first quadrant, and we use Roman numerals when we show that. So for this first one, we'll just write out quadrant. This is known as quadrant 1, upper right-hand corner. Over here, up to the left-hand corner, is quadrant Roman numeral 2. Down below that, we call it quadrant 3. And right next to that is quadrant 4, Roman numeral. That would be IV. Now, when we locate points here in this Cartesian coordinate system, we label them as an ordered pair. Right? The ordered pair we use, for lack of anything sophisticated, we'll just say an x and a y coordinate. The first number is the x coordinate, the second number is y coordinate. This is known as an ordered pair. Obviously, the word pair means two, and there are two numbers that describe any point you could locate here. But this word is also important, ordered, meaning the order matters. So if you have the number 3, then a 2, that's very different, or a different location than a 2 and a 3. And what each of these numbers mean, this first coordinate, this first part of this ordered pair, this first number, represents what we would say is a horizontal move. Horizontal move, and what that means is it tells you how far left or right of the origin you need to move. So it's a horizontal move from the origin. So after you count out your x-coordinate, you're going to be on the x-axis somewhere. Right? So that's the first move. Your second move will be a vertical move. Now, it's not a vertical move from the origin necessarily. I mean, it could be if your x-coordinate is 0, where you stay right at the origin, but it's a vertical move from the x-axis. So from where you left off with your x-coordinate, you now need to make a vertical move. Now, how we determine whether you move to the right or left or up or down is all dependent on the signs. So with your horizontal move, if that x-coordinate is positive, we know that means you need to move to the right from the origin that much. If it's negative, well, you move to the left of the origin that much. And if it's 0, you stay right at the origin. Likewise, for your vertical move, vertical doesn't necessarily mean up. Vertical is up or down. So positive would be an upward move from the x-axis, and a negative would be a downward move from the x-axis. And if it's 0, well, you stay right on the x-axis. So we can locate any point in the Cartesian coordinate system using an ordered pair, as you well know. So, for example, I could pick a point, let's say right here, make it easy. That point has a specific ordered pair associated with it, and there's only one ordered pair that we could ever name this point as. And it has to be our x-coordinate first. So to get to this point, moving left or right first from the origin, I would definitely have to move to the right 4. So that would make my x-coordinate 4. And then I would have to go up, looks like 6 right here. You can see that. So up 6. To the right 4 of the origin, and then from that x-axis location, I need to move 6 directly up. So you can get to any point in the Cartesian coordinate system by making a horizontal move and then a vertical move. Just make sure the horizontal move is from the origin, and then your vertical move goes from the x-axis. Right? So if we pick a different point, let's say, let's go right here. Same idea. To locate this point, it's first a horizontal move from the origin. So in this case, looks like I have to move to the right 8. To the right 8 will be represented as a positive 8. And then from there on the x-axis, 1, 2, 3, 4, 5 down, we represent that as a negative 5. Right? And one of the nice features about the Cartesian coordinate system that sometimes we take for granted is that each point has exactly one ordered pair representation. And vice versa. Each ordered pair representation you can give has exactly one location. Now that's kind of like, yeah, so what? Well, in other graphing systems, and there are others out there, those two relationships don't necessarily hold. Right? So, for example, I could pick a random ordered pair. Just throw in some numbers and say, okay, where's negative 7, comma 4 located? Well, that's a specific location in the Cartesian coordinate system, and there's only one point at this location. So this gives us a roadmap. How do I get there? Well, I have to move 7 to the left of the origin, which puts me right there on the x-axis, and then from there on the x-axis, I now have to move 4 units up, because it's positive. 4, I believe, is right there, and that's the ordered pair, negative 7. Now, as far as what we say about naming these points or what quadrant they're in, sometimes that's asked of us. These 3 points are definitely located within a specific quadrant. We can see that this point 4, 6 is located in quadrant 1. And that's going to be true of any ordered pair where both the x and the y coordinate are positive. That will always be a location in quadrant 1. Likewise, this point at negative 7, 4 is quadrant 2, and that's always going to be the case anytime you have a negative x coordinate and a positive y coordinate. Right? We didn't locate any points down here, but we definitely could. Let's just pick one. If I said, okay, name that particular point, you would say this is 5 to the left, so negative 5, and then 1 down from there. And you notice any point located in quadrant 3 has both a negative x and a negative y coordinate. Always true. And then if you go to quadrant 4, well, you can see that you're always going to have a positive x coordinate and a negative y coordinate. Now, if a point lands on an axis or at the origin, we don't say it's in any particular quadrant. We just name the axis it's on. And we can be specific. For example, if I were to pick this point, that's easy to see. I don't say that this point is in quadrant 1 and quadrant 2. I would say it's on the y-axis, and if I wanted to be even more specific, I would say it's on the positive y-axis. But I would never say it's in quadrant 1/2. That's not the way it works. If it's on an axis, you say it's on an axis, and you can even be specific. This is the positive y, that's the negative one. Positive x, negative x. And by the way, this point has 0 for its x coordinate. You don't need to move left or right of the origin at all. It's just directly above it, 12 units. So we would identify that as 0, 12. Right? So this is pretty much your, short, brief refresher of the Cartesian coordinate system. I would dare say that none of this stuff, really is anything that you learn new. Just you have to know this, and we have to be very clear about how these ordered pairs work. It does matter whether you say, for example, 4, 6 or 6, 4. 4 over 6 up is that point. 6 over 4 up is a totally different location. Right? It does matter. That's why we call them ordered pairs, not just, hey, they're pairs. They're coordinate pairs. They're ordered pairs. Order makes a difference. All right, in our next video, we'll see some examples of how we graph these and how we write equations.